All right, this is AP Calculus, and we have moved to Chapter 4. All right, so we're going to be in Section 4 for a couple of lectures. So we'll call this lecture 4.1a. There will be also a 4.1b. So we've been doing differentiation for a long time now. Well, we're going to reverse the process. This is called antidifferentiation. And that is a process or operation that reverses differentiation. So we're going to learn to go backwards. So let's do a few simple examples. So let's start with a question. All right, its derivative is 2x. Okay, what function, when you take the derivative of it, you get 2x? All right, well, the answer, maybe you can do this, is f of x is equal to x squared. So we reverse the process. Take the derivative of x squared and you'll get 2x. All right, here's our question. We're going like the Jeopardy route. Its derivative, since Alex Trebek just recently passed away at 90, I believe. Surely that can't be right. Maybe it's 80. All right, its derivative is 3x squared. All right, drum roll please. Can you think of the answer? Well, it's going to be x cubed. Take the derivative of x cubed, 3, bring it down front, subtract 1, 3x squared. All right, we're starting off with some easy ones. Next question. Right, its derivative is sine x. Well, you know it's probably something to do with cosine x. The derivative of cosine is minus sine, though. It's not sine, so we're going to need to put a minus out front. So that would be minus sine x times negative 1. That would give us a positive sine x. So let's see if we can fit one more in here on the board. All right, its derivative is 1 over x squared. All right, that's pretty messy. Let me try to improve that. 1 over x squared. I'm working around the music stand here. Let's rewrite that as x to the minus 2. All right, so if I reversed differentiation, well, we know it'd be x. I like to think of the exponent first to the minus 1, right? So when I take the derivative of that, subtract 1, I'd come up with minus 2. But I'm going to need a minus out front. So it'd be minus x to the minus 1. Negative 1 times the negative out front's positive, and then x to the minus 2. Well, let's rewrite that to get rid of the negative exponent. So that'd be minus 1 over x. Okay, pause the video if you need to. All right, we'll do one more of these Jeopardy types. All right. Guess it's really not like Jeopardy, is it? It's derivative is the square root of x. Well, let's rewrite that in fractional form. So that'd be x to the fractional exponent form, x to the 1/2. All right, so our original function, if we take the derivative of it, we'll get x to the 1/2. Well, I need to add 1 to the exponent, so that would be 3/2. But what do I need out front so that when I bring the 3/2 down and multiply, I end up with just a 1? Well, it's going to be 2/3. Right? 3/2 times 2/3 is 1, and then subtract 1 from 3/2, and you would get 1/2. And that's fine. Leave it like that. You do need to fix negative exponents, but you don't have to fix fractional exponents. So our general rule okay, and I'm going to introduce a new symbol. It's this real skinny S. Okay? We call that an indefinite. So we're going to have a definite one in a few days. Integral. So that skinny S thing is called an integral. All right? Of f of x dx is equal to big F of x. What that means is if I have f of x dx, if I take the antiderivative, that skinny s, that integral means, is a symbol that means take the antiderivative of that. You get the original function. All right? Dx is the variable of integration. All right, so you get the big parent function there. If I were to take the derivative of that big parent function, big F prime of x, you're just going to get little f of x. All right, so big F of x is what we call the antiderivative. Okay, I'm going to erase that. Okay, so if we are taking the antiderivative of x to the n dx, okay, that is the power rule for integration. Here's the formula. You add 1 to the exponent, x to the n plus 1, and then you divide that by n plus 1. And then plus c. We'll talk about the plus c in a minute. It's a constant of integration. This formula is called the power rule for integration. Okay, now I'm going to do it a little different than that. It ends up being the same thing, but I think it's easier for you now. In this case, n cannot be -1. All right, or you'd have a 0 down there, right? Okay, so let's do an easy example. Let's say you're given the skinny symbol, that integral, 2x dx. That's just saying take the antiderivative of 2x. Well, that's x squared, and then plus c. And the reason that you have to put a plus c is any constant has a derivative of 0. Okay, so if we were to take, let's say we had x squared plus 7. Let's say we have y equals that. Y prime is going to be just 2x, right? Doesn't matter that there's a 7. Let's say we have y is equal to x squared plus 5. Y prime is still going to be 2x. So you have to put the c for constant because it could be anything, any number, you know, without a variable in it, and the derivative is going to be 0. So that's what the c stands for. All right, I got a bunch of examples for you. Actually, I lied. I got one more thing to write. Let's consider. All right, you have the integrand. All right, we want to integrate c times f of x dx. Well, you can bring that c out front. Okay, so an example of that would be, let's integrate 5x cubed dx. We could rewrite that. We could bring the 5 out in front of the integral, or the integrand, x cubed dx. And that's going to be 5 times, okay, that would be x to the 4th, right? We're taking the antiderivative, and we need a 1/4 out front. 4 times a 4th is just 1, and then x cubed. And then I just multiply all that by 5. So that would be 5/4 x to the 4th plus c, our constant of integration. You could check it. Take the derivative. 4 times 5/4 is 5x cubed. Subtract 1. All right, one more consideration. Let's say we are taking the antiderivative of f of x plus or minus g of x dx. We can split that up into f of x dx plus or minus the integral of g of x dx. It's much easier to split them up into two separate functions and integrate them separately. All right, I've written all that down. I got a bunch of examples for you. Okay, so first example, we want to integrate cosine x dx. Well, that would be sine x plus c. How do you check it? Take the derivative. Derivative of sine is cosine. Derivative of c is 0, so we're right back to the beginning. All right, let's integrate secant squared x dx. Well, what function, if you take the derivative of it, gives you secant squared? Well, it's tangent. All right. Now in the book we're on page 248, so let's look at example 8. You don't have to go there because I'm going to write the problem down. But it says integrate x times x squared plus 3. Well, what we need to do is just multiply the x by each term. So that's going to be x cubed plus 3x dx. And now we can integrate those separately. Well, what's the antiderivative of x cubed? Well, it's x to the 4th. I do the exponent first. And then what fraction do I need out front so that when I bring the 4 down and multiply, I just get a 1. That's 1/4. So we'd have 1/4 x to the 4th plus, all right, for this one it's x. We know it's going to go up to x squared. So what fraction out front do I need when I multiply it by 2? I'll have a 3. Well, that's going to be 3/2. 2 times 3/2 is 3. Plus, don't forget your constant of integration. I do on the test count off 1 point every time you forget to write the c. Right, that's a big deal in calculus land. I think I had a student one year do that 7 times on a test. I think he made a 93. That's the only thing he missed on the test. Was all of that. Example 22. So we're still on page 248. It says integrate 1 over x to the 4th. Okay, let's rewrite that as x to the minus 4. Okay, so we want to add 1 to that. That's x to the minus 3. So we're not subtracting like we did when we took a derivative. And I need something out front. When I bring that negative 3 down and multiply it, I end up canceling, and there's just a 1. So that's going to be negative 1/3. All right? Negative 3 times negative 1/3 is 1, then x to the minus 4. So that would be, we do want to clean up that negative exponent, negative 1 over 3x cubed. All right, look at us go. All right, let's throw some trig in there because I know that'll make you happy. Let's integrate theta squared. So theta is just, it's just a variable like an x. So don't poop a brick if you see theta or any other Greek symbol. Our constant of integration, though, would be d theta instead of dx. Okay, well, that's just going to be 1/3 theta cubed, right? Take the derivative of that, and you'll come up with theta squared. And then we've already done the secant squared plus tangent theta. Oh, what did I do here? I forgot the plus c. Take off a point from Mr. Wooded. Right, plus c. Okay, one more to go and we're done with this lecture. All right, example 46, we're on page 249. Okay, that one gives us a function, and it says that dy dx is equal to 2 times x minus 1. And it gives us the point that it gives us is, I don't have the book open, I'm trying to find it. It is 3, 2. All right, x is 3, y is 2. So we're trying to get to the original equation, the y equals something. So first of all, we want dy on one side, and then 2 times x minus 1 dx. See, I just brought that dx over here. And we're going to integrate both sides. So we'll integrate that side, integrate that side. So what is the antiderivative of dy? Well, it's y. Take the derivative of y, and you'll just get dy. Now I'm going to go ahead before I do this and distribute. So that'd be 2x minus 2 dx. Okay, antiderivative of 2x is x squared. Antiderivative of 2 would be minus 2x. Oh, please be careful. So many people will take the antiderivative of that, and then I'll see that take the derivative and say it's 0. But it ain't. All right, we need the c. Now we're going to plug in this 0.32 and solve for c. So if y is 2, x is 3. So we have 2 is equal to 9 minus 6 plus c. All right. Did I do that right? So that'd be 2 is equal to 3 plus c. So negative 1 is equal to c. So now we can go, we're just going to plug negative 1 in here for c, and that's our answer. So y is equal to x squared minus 2x minus 1. Again, that negative 1 is our c value that goes right there. Okay, let me give you, I'm going to write down the homework. Of course, the homework will be on Microsoft Teams. It'll be on the Weebly website. There are no even answers to give you. Okay, but I'm going to go ahead and write the homework here so that's convenient for you. We're on page 248. I want you to do 5, 7, 9. Looks like a lot, but these will go fast. 15, 17, 19, 21. It's like when you first learned to take derivatives, went pretty fast. 23, 25, 27, 29. I probably could have consolidated this, couldn't I? 5. Let's see, we skipped 11 and 13, so it'd be 15 through 35 odd. Did I say, is that right? 15, 17, 19, 20, 23, 20. Yeah, let's do it that way. So sorry. 5, 7, 9. 15 through 35 odd. And then we're also going to do 45 and 47. These are like example 46. Okay, so that's your homework. Make sure if you have trouble that you ask me to work them. I can either do it over a live video or I can make a YouTube video for you. And that is your first lecture where we've moved beyond derivatives into antiderivatives. So I'll talk to you next video.